Hi students, I have brought it for you the continuation topic from the yesterday's one. In our previous class, what we had studied just about substitution reactions in this electrophilic substitution and nucleophilic substitution and free radical substitution also completed, right? And what about the last type? Here you can see the combustion reactions and oxidation reactions also. In our yesterday's session I had completed. Once you can check the description, I'll provide for you all the links in that, so you can go through them. Now students, in this session we have to study about addition reactions, okay, and elimination reactions also in this session. In this addition reactions also, again we have to study about nucleophilic and electrophilic and free radical also. In these free radical reactions, initiation, propagation, termination, about these three we had studied about substitution reactions. Let's see now in these addition reactions. Let's know the definition of this addition reaction. The reactions which involve combination between two reacting molecules to give a single molecule of the product. This is called as an addition reaction. Such reactions are typical of compounds containing multiple bonds, nothing but double bond and triple bond. So these addition reactions typical in the multiple bonds. Depending upon the nature of the attacking species, you know that's electrophile and nucleophile or free radicals. These three are the attacking species. Addition reactions are the following types. Those are, as I told you in that mind map only: nucleophilic, electrophilic and free radical addition reactions. Let's see one by one. First of all, the first one is nucleophilic addition reactions. In this type of addition reaction, the addition reactions brought about by nucleophiles are called nucleophilic addition reactions. These reactions are typical of aldehydes and as well as ketones also. So these addition reactions are typical of aldehydes and ketones. For example, base catalyzed addition of HCN to aldehydes or ketones. Now let's see that. OH minus plus HCN. Then students, what are the products? Here H2O with this Cn minus. Here this Cn minus is acting as nucleophile. Okay. Here from this, the attacking of these electrons towards hydrogen and here towards this cyanide. So Cn minus ion can be formed. This is acting as a nucleophile here. And if you take the example of ketone C double bond O, here R and R. So plus Cn minus, if you add one nucleophile to this Cn minus, now students, attacking of towards the carbon, attacking of this attacking species of this nucleophile towards this carbon, then the shifting of here the electrons towards this O. This is only ketone and this is acting as nucleophile. Then the formed product should be, this is the product 1, okay, from this Cn here minus Cn minus. Now from this negative ion, attacking of this electrophile towards this hydrogen, now the shifting of electrons like this, then the formed compound is RCOH. Here R, here Cn. The name of this compound is ketone cyanohydrin. Ketone cyanohydrin. The formed final product is known as addition product. So this is ketone cyanohydrin. This is about nucleophilic addition reaction. Now let's see about the electrophilic addition reaction. Let's see the definition. Addition reactions brought about by electrophiles are known as electrophilic addition reactions. These reactions are typical of alkenes and alkynes. Alkenes and alkynes also. These two are the unsaturated compounds. For example, addition of Br2 and HBr. Br2 and HBr to propylene. Let's see now. Propylene means CH3, CH double bond CH2. This is propylene. To this, here is the H plus ion, and from this double bond, the transfer of electrons towards these H plus ions, this is a slow reaction, and here the formed product is CH3 twice CH. Due to this transfer of these electrons, here plus ion should be formed. This is known as isopropyl carbocation. Isopropyl carbocation. At this second carbon, here is the positive charged positive ion, so this is known as secondary carbocation. Okay, now students, to this CH3 CH, here is the positive charge and here CH3. To this, if you add Br minus, now this is the fast reaction, and from this negative ion, the transfer of electrons towards this hydrogen and towards this carbon, on this carbon positive ion can be formed. Already here is there, so the formed product should be CH3 CH, CH3 Br. Now this is about electrophilic addition reaction. The name of this compound is, here 1, 2, 3. 3 carbons are there, then the root word should be prop, and at the second carbon, bromine substitute is added here. So 2-bromo-propane is the IUPAC name. This compound is known as addition product. Okay students, let's see now about free radical addition reactions. Third type, free radical addition reactions. Here is the definition. Addition reactions brought about by the free radicals is known as free radical addition reactions. For example, addition of HBr to alkenes. Here is the alkenes. You have to take that the formed propene. Okay, in the presence of peroxides. Peroxides nothing but this is the hydrogen peroxide, and in the presence of any peroxides you have to take. Okay, now let's see the example for this reaction, free radical addition reactions. First one, propene. Here is, instead of alkene, we have to take that propene, CH3 CH double bond CH2. So this is the alkene. The name of this alkene is propene. Right. To this propene, if you add HBr in the presence of peroxides, now the formed compound is CH3 CH2 CH2Br. So the name of this compound is N-propyl bromide. Okay, now this reaction occurs by initiation and propagation and termination also. Now let's see the first one, initiation. The first step is initiation. Let's see now. ROR. This is peroxides. Here is the single bond, that means here presence of 2 electrons takes place. Now due to the homolytic fission, Here is the presence of single bonds, that means presence of 2 electrons. So these 2 electrons can be shared with each of them. So one should be towards like this, one should be towards this RO. Okay, due to that homolytic fission. Now students, the formed compound is just radical formation 2RO. This is alkoxy free radical. Alkoxy free radical should be formed due to this homolytic fission. Now to this RO, here is the radical. If you add HBr, so this free radical moves towards this hydrogen, then this bond shifted like this, then students ROH plus Br, bromine free radical should be formed. Bromine free radical. This is about initiation. The first step, initiation. Now let's see the second step, propagation. In this propagation, if you take the example of CH3, CH double bond CH2, to this if you add Br, bromine free radical, now the shifting of the electrons here is like this and here towards this bromine. So this is slow reaction. Then the formed compound, let's see now, CH3, CH, radical CH2, Br, CH2 Br. So the name of this compound is isopropyl free radical. At the second carbon, radical formation is there, so it belongs to secondary one. Now to this formed isopropyl free radical, if you add again HBr, okay, this is fast reaction. Now here is the free radical. Now this shifting of this free radical towards this hydrogen, and here is the presence of bond from this also like this. Now the formed compound is CH3, CH2, CH2Br plus Br, bromine radical. The name of this compound is N-propyl bromide. N-propyl bromide. Now let's see the third step, termination free radical addition reaction, termination step. Here is the bromine radical plus here is the another bromine radical. By mixing of these two, Br and Br, just like Br2 molecule should be formed here. So this is about termination reaction. Now students, this is about complete information of free radical addition reaction. Here again we have three types: initiation and propagation and termination. Right, this is about addition reactions. Now let's go for elimination reactions. In this mind map, elimination reactions are of three types: alpha elimination, beta elimination and gamma elimination, due to just because of the positions of the atoms or groups eliminated. Okay, let's see the first one, alpha elimination reaction, with a definition. First of all, what is meant by elimination reaction? You have to know. An elimination reaction is that involves the loss of two atoms or group of atoms from the same or adjacent atoms of a substance, leading to the formation of a multiple bond. Multiple bond, nothing but single bond or a double bond or a triple bond. These are the multiple bonds. Okay students, and let's see now clearly. An elimination reaction is one that involves the loss of two or group of atoms from the same or adjacent substances, adjacent atoms of a substance, leading to the formation of a multiple bond. Okay, depending upon the relative positions of an atoms or group of atoms eliminated, these reactions can be. Coming to the first type, alpha elimination, let's see the definition of this. In these alpha elimination reactions, the loss of two atoms or group of atoms occurs from the same atom of the substrate. From the same atom of the substrate molecule. Here substrate molecule nothing but the reactant molecule which is involving in that organic reaction. Okay, now let's see the example of this. Base catalyzed dehydrohalogenation of chloroform to form dichlorocarbene. Let's see now. Here is the OH minus ion. To this, if you add chloroform, here is the chloroform, and the formed products are CCl2, lone pair of electrons with H2O and Cl minus. Okay, now see the changes involving in this. What is the mechanism? The shifting of this negative charged ion should be towards hydrogen, and now like this. Okay, now the name of this compound is dichlorocarbene. The dichlorocarbene is the reactive intermediate involved in carbylamine reaction and Rearrangement reaction. About these two I'll discuss with you afterwards. Here is the chloroform CHCl3. So this is about alpha elimination. Let's see now beta elimination. So in these beta elimination reactions, the loss of two atoms or groups occur from the adjacent atoms of the substrate molecule. Adjacent atoms of substrate molecules. For example, acid catalyzed dehydration of alcohols. Acid catalyzed dehydration of alcohols. Here is the example. CH2, CH2, OH. The name of this compound is ethanol. Here OL is the suffix, and here is alpha carbon and here is the beta carbon. Then the shifting of the electrons towards like this, and in the presence of concentrated H2SO4, the formed products are CH2, here CH2, C2H4. The name of this compound is ethene plus H2O. Okay, this is about acid catalyzed dehydration of alcohols. Now let's see the base catalyzed dehydrohalogenation. In this type of base catalyzed dehydrohalogenation of alkyl halides, a basic substance is acting as a catalyst. Why? Because in this acid catalyzed dehydration of alcohols, an acid H2SO4 is acting as a catalyst here. Now let's see the examples of this. Then HO minus, CH2, CH2, Br. So here is the alpha one, beta one. Towards this carbon like this. The name of this compound is ethyl bromide. Ethyl bromide. In the presence of KOH, basic medium, if you heat the compound, then CH2 double bond CH2. Here also same ethene. Ethene should be formed including with KBr with water. This is about beta elimination. Two types, in the medium of acid catalyzed and the medium of basic catalyzed. Then catalyst, basic catalyst, and alpha position of alpha elimination also we studied about this. Chloroform, then dichlorocarbene ion formation, and here beta elimination from the adjacent atoms, just like this. These are the examples. Now let's go for gamma elimination. The third type is gamma elimination. In these types of gamma elimination, loss of two atoms or group of atoms occurs from alpha and gamma positions, that is 3 bonds away. 3 bonds away. These are the gamma positions of the molecule, leading to the formation of 3-membered rings. 3-membered rings means, example here we have to take cyclopropane. So prop means there must be a presence of 3 carbons. So here are the hydrogens, then here hydrogens, here also 2 hydrogens, then here 1 bromine and here 1 bromine. So the name of this compound is cyclopropane. Attacking should be done, this is the position of gamma, towards this gamma position carbon, and here is the beta one and here is alpha. And students, in the presence of zinc dust, this is known as alpha elimination. And what is the final product? So here is the carbon, here also a carbon. So as usual, these are the hydrogens plus ZnBr2. Here cyclopropane, and here the formation of hydrogens. This reaction is called as Freund reaction, Freund, Freund reaction, and is extensively used for the synthesis of 3-membered rings. Okay, this is about gamma elimination. Now students, let's see for the 4th one, condensation reactions. Let's say the definition of this condensation reaction. In these condensation reactions, 2 or more molecules of the same or different reactants combine to form a product. In this product, with or without the elimination of simple molecules such as H2O, HCl, NH3, ROH. These are the simple molecules. With or without the elimination of these simple molecules could be done in the product. And for this example is acetaldehyde. The 2 molecules of acetaldehyde condense in the presence of dilute alkali to form the products. Let's see the equation. 2 molecules of acetaldehyde condenses in the presence of dilute alkali. Dilute alkali, nothing but dilute NaOH. NaOH, which is in dilute condition. Then what we have taken, the taken product, the compound is ethanol, or the name of this is acetaldehyde. Here is the changes, just like this, from this single bond towards this carbon. Here is the product, CH3, CH, CH2, C double bond O, H, here CHOH. So if you want to give numbering to these carbons, 1, 2, 3, 4. At this 3rd carbon and 1st carbon, here is the oxygen and here is OH. So 3 hydroxy butanol. This formed 3 hydroxy butanol. Again it is heating with dilute mineral acids. Just I'm going to write the equation here. This is the compound CHOH and CH2 CHO, and heating with this hydronium ion. This is only 3 hydroxy butanol. Now the formed compound is CH3 CH double bond CH CHO plus H2O. The name of this compound is but-2-enol. So here is the aldehyde group and here is the alkene group, so due to that double bond, this compound is also called as crotonaldehyde. Okay, this is the complete reaction. If the 3-hydroxybutanol, the name of this 3-hydroxybutanol is aldol. This aldol, on heating with dilute mineral acids, readily undergo dehydration to form alpha beta unsaturated aldehydes or ketones. This is the complete equation. Now, an example of condensation reaction which occurs with the elimination of a molecule of H2O is the reaction between benzaldehyde and aniline to form benzylidene aniline. Let's see that example. This is the condensation reaction which occurs with elimination of a molecule of H2O. It is the reaction between benzaldehyde. This is the benzaldehyde formula and aniline to form here the products C6H5 CH double bond N C6H5 with the elimination of water. The name of this final product is benzylidene aniline. Okay, now the elimination of H2O. Here is the molecule of H2O. Then this could be eliminated. So students, this is about the condensation reactions. Next type of chemical reaction, let's see now, rearrangement reactions. Here is the definition. These rearrangement reactions involving the migration of one atom or group of atoms from one atom to another within the same molecule. So this is the definition. For example, I'm going to write here dehydration of 2,2-dimethyl propane. So this is CH3, this is C, CH2, OH. So this is the second carbon, 2,2-dimethyl. So at this second carbon only 2 methyl groups can be attached. So in the presence of concentrated H2SO4, through that the formed through 1 and 2 migration of the methyl groups to give rearranged product, that is CH3, again CH3, here is CH3, CH2, OH2. Okay, from this removal of H2O, you should get finally CH3, CH2. This is primary carbocation. It is less stable. Primary carbocation, less stable now. And the name of this compound is 2,2-dimethyl propanol, 1 ol. At this first carbon, alcoholic group is located. From this, you should get finally, if you remove this H plus ion, then CH3, C, CH3, CH2, CH3, here is the positive ion. So this is tertiary carbocation, which is more, this tertiary carbocation is more stable, and from this if you remove one H plus ion, now the formed compound is CH3, C, CH3, now CH, CH3. So here is the CH2, CH3. From this if you remove one hydrogen, then CH, CH3. The name of this compound is, now here is the double bond. Okay, 2-methyl but-2-ene. So this is an alkene group with this double bond, 2-methyl but-2-ene. This is about the first example, the dehydration of 2,2-dimethyl propanol. Now students, number 2, second example, Euler synthesis of urea from ammonium cyanate. from double decomposition of mixture of NH4Cl and sodium cyanate NaCNO by heating. So the formed products are NH4CNO plus NaCl. Okay, now you have to take that ammonium cyanate NH4CNO. Yes, to decompose this ammonium cyanate, then students, NH3 with these single pair of electrons, triple bond N. These pair of electrons shifted towards this carbon. Now obviously like this, the bond also, ammonium cyanate. From that equation we have finalized that HOC, here is NH3 with positive charge, double bond N minus. So here is the proton transfer. Proton transfer takes place. Now HOC NH NH2. Now students, from this the tautomerizes also could be done here. Tautomerizes. Now NH2 NH2. This is the synthesis of urea from ammonium cyanate. This is urea. Okay students, this is about our today's session. Just we have to recall what we have studied in this session about addition reactions completed. These three types, electrophilic, nucleophilic and free radical also. In this free radical type, initiation, propagation, termination also completed again. And these elimination reactions, alpha, beta and gamma elimination. In this beta elimination, base catalyzed and acid catalyzed dehydration process completed, and rearrangement reactions completed, and students condensation also completed. And the leftover topics should be isomerization, pericyclic and polymerization. About these three I'll be discussing with you in our next session. Thank you so much. Thanks for watching. If you understand this class, you can subscribe to this channel, can share to your friends. Okay students, thank you so much. Have a nice day.